Hi everyone, welcome back to my channel. My name is Razia. Today I'm going to dive into some exciting advancements in medical field, and specifically we will be looking at the focused ultrasound as to how it plays a vital role as a therapeutic intervention as well as diagnostic purposes, of course, because it is primarily used for diagnosis. But then there is a lot on the other side that we don't really know, and it is always good to keep up with the facts, right? So I'm making this small little video because there are so many evolving theories around focused ultrasound. So recently we came across nitric oxide. Um, as we all know, this is like the analgesic drug that is like the anesthetic agent, as well as it has immense potentials of doing so many beautiful things. So we will be diving into it in a deeper aspect, on a deeper side. And also we will be talking about the dynamic clips of ultrasound machines, how this comes into play, what are like the brief flashes that can come out as being most important in the lab settings as well as in the clinical settings. So I will be walking through some technologies that are revolutionizing the way we approach treatments, especially when it comes to the drug delivery system in the blood-brain barrier. And when we want the drugs to go all the way across the brain areas, we do need some kind of neuromodulation. And this can come out as a potent therapy for the infections or maybe cancer therapy overall. So this modality is used for uh, immense opportunities, one of which is the gene therapy. So for non-invasive ultrasound techniques, we have a lot of precision because we are placing our targeted tissue into play. So this requires a controlled setting, a precision to be more important. And we do not want the neighboring tissues to be affected. And we do not want to pose the risk of radiation at the same time. So it is very, very effective modality of choice. By using nitric oxide, we have merged through different walls, and the future of medicine is getting only steeper and steeper with a sharp bounce because ultrasound is taking over every intervention possibly. And it is safe, it has no risk of radiations, no risk of any uh, side effects following the procedure. And so as a medical student and as a science enthusiast, I am delving into how this works out. What we will simply look at the images, and we will also look at how this whole gaseous system is coming around and making its way to the brain. So stick with me throughout this video. We will be breaking down the basic strategies on the latest techniques through the research work, through the incredible work that is being done through all the universities through the mentors and everyone out there. So we are simply advocating. No, we are not. Are we simply talking about the therapies? Possibly no. We are just giving the insight on the newer techniques to the audience. This is my like you can say my message to the audience. I'm not copying anyone. I'm going to in fact bring out all the authors names, and then we will simply delve in to know the techniques, because knowing these techniques will give us an edge to the research in future. I mean, you can use this as your main choice of research as well. So if at all you like the topic, you can reach out to me, and then we can collaborate on making new research studies on this particular topic. Okay. So let's call it a day, and I mean, let's just stop here and delve into the concept. Okay, so let me share my screen. I hope you can see my screen. So, as I was talking about nitric oxide in the earlier uh, video, I would like to emphasize on the preclinical studies that I really, really admire and look forward to work with. So here we have used a mice model. So this is from the Frontiers paper. Okay. The authors have used a mice model. They have dissected all throughout with proper septic precautions. And it is very, very difficult actually to dissect and get your way to the jugular vein, because the veins are very teeny tiny. You we we tend to even miss out on these techniques. So it is very, very precise. We need lot of delicate stuff added to this. It is very important to mitigate the damage to the mice models. But then this is like the foundational studies that are very important to carry out on the clinical trials, so that the procedure is being approved by the FDA in the market. So things work really, really different here in the States. So it's very controlled, and it is very precise at first place. We do preclinical studies for several other purposes. Other than this, preclinical studies carry a huge weight in terms of carrying a clinical research. So the clinical research doesn't really start out of blue. It is the basis from uh, the preclinical studies that have been ongoing in the universities. And this basic idea, if it has to be carried all the way to the humans, it needs a source. So yes, there is a downside. We do look at the downside, but then the downside outweighs, because the results obtained from the preclinical studies are not just there for us. The future directions it leads us to is very, very uh, essential for the clinical trials to be carried on human subjects. So I really, really, I am so much into this, because it's like incredible to come up with such techniques. Um, at first place, right? So look at this. It is the nitric oxide that does wonders. It's loaded and produces micro bubbles, meaning the bubbles are like loading all over on the top. Okay. So if you see the each micro bubble, there is two components that are inside the bubble. One is the nitric oxide itself, like the gaseous element, and then there is SF6. So it is, you can imagine it is a lightweight kind of a bubble, but then this bubble is just sufficient enough to break open the barrier in the brain, causing the drug delivery system to be more efficient, such that gene therapies can be a great way to study in detail. So in this particular study, the gene therapy was um, highlighted through the nitric oxide. So you can also see there is this ultrasound, right? So but then this requires a very low radiation, and the pressure required is also very low. Okay, so the focused ultrasound is making all the way from this particular site to um, and this is how we made out that the integrity of so-called the endothelial cells are lost. They have clumped up the clot formation, meaning the injury is evident. So, this was tried on the mice. It serves as a proof that nitric oxide has the ability to kind of break through the endothelium. Okay, the similar thing was being tried in the brain as well. So there also we saw these SF6 molecules, nitric oxide molecules, and microbubbles making the way to the brain, around the brain, and beyond the blood brain barrier. Okay, so let's quickly delve into this paper for today. So we can see there are so many authors that are linked to this particular paper. And this was done in the blood vessels, like we saw in the picture. It was to see if the nitric oxide really has the ability to protect against the injury. Going all the way down for the results, because if I sit and study, it may take a bit of time because we do need the facts. So the fact that there is a lot to study on this paper does keep me interested, but I want to keep this video short. So let's delve into the results right away. So ultrasound, what is UTMT? 1 second. I don't want to go saying wrong things, so I would like to confirm it. What is this? UTMT. All right, yes, it's ultrasound targeted microtubule distraction. Okay. So this definitely, they're saying that it does have a great potential in targeting the genes, the gases to the various organs. Mm, So they've used a lot of gases to be more effective and more precise. Uh, let's For summing up this whole video, I would like to add few important points as to how the nitric oxide techniques like focused ultrasound aids in the process. Okay, so yeah, we got this. So ultrasound treatment microtubule is really, really effective. It enhances the thrombolysis, meaning it's capable of dissolving the clot, and this is by activation of enos, that is the guanyl cyclase activity, increasing the cyclic AMP levels, and activation of guanyl cyclase overall results in stretching away the microvessels, leading to vasodilation and release of nitric oxide. So, this study definitely has a potential of translating in the clinical trials. Um, s- and we can see how the clinical, preclinical areas contribute to the research field. So there it is. Now you know that preclinical studies are not just about mice or mice models, it's more than that. All right, so that is what I wanted to convey through this particular video. Stick with me in the next few videos. I may come up with some random topics, some interesting topics, and some interesting facts. And give me a thumbs up if you like it. All right. I will take a leave right now. I will see you in the next video. Till then, keep studying hard and keep it within the loop. Bye.